All right, today's lesson is conditional statements, also known as if-then statements. So some teachers might say if-then statements, some teachers might say conditional statements. Know that they're the same. Conditional statement is a statement with a hypothesis followed by a conclusion. Definition of a hypothesis generally comes after the if, but before the then. In shorthand, we abbreviate it as the letter P. The conclusion comes after the then. In shorthand, it's abbreviated with the letter Q. So if I take a look at these statements here, let's identify what's the hypothesis and what's the conclusion here. So first statement, if you work overtime, then you'll be paid time and a half. So the hypothesis is what's between the if and then. So this is the P, the hypothesis. The conclusion, you'll be paid time and a half, which came after the then, is the conclusion. Notice that I didn't box in the if or the then, and I didn't underline the then as well, okay? Because those aren't actually part of the hypothesis and conclusion. Statement number 2, I'll wash the car if the weather is nice. This one switches it up a little bit. Turns out the hypothesis, the weather is nice, right, isn't always at the beginning. We've got to be careful. We've got to look for those markers of if and then. The conclusion, therefore, I'll wash the car. Let's look at the third statement. If 2 divides evenly into x, then x is an even number. So if and then, what's in between is the hypothesis. So there's my P. And what comes after the then is my Q. Statement 4 becomes a little trickier, right? There's no if and then here. When is there? So I'll be a millionaire when I win Monopoly. When is really a hidden if. So the P is I win Monopoly. The Q here is I'll be a millionaire. What about this last statement? This one's a little trickier. All equal angular triangles are equilateral. There's no marker. There's no when. There's no if. There's no then. All right. We'll learn a little bit more about these statements right now. But what I want you to try to gauge is, can you change it into an if-then statement? All right. There are 2 parts here, and they're usually split by the verb. Right. So the verb is are. So we've got 2 parts. We've got equal angular triangles and equilateral triangles, right? So if a triangle is equiangular, then it is equilateral. So now when I take a look at this, a triangle is equiangular is my P, and my Q, it is equilateral, is my conclusion. So, converse, inverse, contrapositive of conditional statements. So if the original statement is, if the weather is nice, then we'll wash the car. We have a shorthand is written P. Then we have an arrow, which is called the if-then arrow, Q. Now, that's the original statement. If P, then Q. The converse switches the two. So now we have if Q, then P. How does that change the statement? Well, we've got an if, and we have a then. But the P and Q switch spots. So the converse of the original would be, if I'll wash the car, then the weather is nice. Now, mind you, sometimes the converse isn't going to make sense. But however, what we're going to assess you on is whether or not you can write it. All right? So be aware of that. Sometimes when you write the converse, you're going to be very confused, like that doesn't make any sense. That's okay. Because what we're looking at is, can you construct it? Can you create that converse? The inverse is if not P, that little symbol is the not symbol or negation in logic, then not Q. So when I look at this, I've still got the if, and I've still got the then. And I've still got my P and my Q, but I need to negate it. So I need to add in, if there isn't a not, you need to put in a not. If there is a not, you need to take it away. So I need to put a not here. And let's fix this to be nicer. I will not wash the car. So if the weather is not nice, then I will not wash the car. That's the inverse. The contrapositive is the converse of the inverse. So, not Q, then not P. We still got our if, and we still have our then. The P and the Q are going to switch, and they will negate. So, you need to change that to I will not, and need to add a not here. So the converse would be, if I will not wash the car, then the weather is not nice. Let's take a look at a couple of examples here. First example, if it has been raining, then the sidewalks are wet. So, identify what's the hypothesis and the conclusion. Remember, converse switches the two. So this is Q, if Q, then P. So I write out the converse here. If the sidewalks are wet, then it has been raining. The inverse, recall that's when you negate the hypothesis and conclusion. So I'm going to write this one out. If it has not been raining, then the sidewalks are not wet. So that's the inverse. Contrapositive, remember, is the converse of the inverse. So not Q, not P. So if the sidewalks are not wet, then it has not been raining. Oftentimes we'll ask you about the truth value of each statement, at which point you need to tell me whether or not it's true, and if it's false, you need to provide some sort of counterexample. Give me a reason why that might not always be true, okay? So let's grab a pen. All right, so let's look at the converse. If the sidewalks are wet, it has been raining. That could be false, right? Because, for instance, a sprinkler could have made the sidewalks wet. The inverse, if it has not been raining, then the sidewalks are not wet. Again, false. For the very same reason as above. And the contrapositive, if the sidewalks are not wet, then it has not been raining. A little tougher to think about, but that's actually true. All right, next example. If a number is divisible by 2, then a number is even. So, converse is if the number is even, then a number is divisible by 2. Inverse, if a number is not divisible by 2, then the number is not even. Contrapositive, if the number is not even, then a number is not divisible by 2. Let's figure out the truth value of each statement. Converse, if a number is even, then a number is divisible by 2. That's true. Inverse, if a number is not divisible by 2, then it is not an even number. That's true. And if the number is not even, then a number is not divisible by 2 is true. Next example, two complementary angles form a right angle. This one is not written in if-then form, so we need to write it as an if-then statement. If two angles are complementary, excuse me, then they form a right angle. So converse, if two angles, so remember this is where P and Q switch. If they form right angles, then they are complement. Then two angles are complementary. Inverse, if two angles are not complementary, then they do not form right angles. And the last one, if two angles do not form a right angle, then they are not complementary. Think about the truth value of these statements. If you remember what complementary means by definition angles that sum to be 90 degrees. It turns out that every one of these are true. So this is true, true, and true.